So let's see. So here's the foundational material that all of the other tutorials that you've seen are kind of based off of. And these are very short. This one's only 14 slides long. But looking at the communication between activities. And I want to show you a little bit more on the concept, just in case you haven't gotten the big picture yet, because it's really hard to get some of the big pictures when you're looking at trying to make something work. So you could create, in this particular case, the goal here is to create an application that has 3 activities. We're not going to do this, we're just going to look at a slide that has it on here. A main activity and then 2 sub-activities. And so we're going to introduce 2 different methods for the interconnectivity communication. We have a message return, and then we have this concept of static variables that we can set. Static variables can hold the information. So if we have, for example, these 3 screens that we're looking at, actually it's 2 screens that we're going to send back and forth. We can invoke, this is the main screen in the middle, this is the activity interaction. We press the button. If I gave you a quiz right now, probably I'm thinking a good percentage of you can probably make a button open up another activity. And if you can find the intent code, or the on-click code. I'm not going to give you a quiz. Everybody pays attention when I say quiz. If I were to test you right now, you probably could figure out, I'm hoping at the end of this weekend you can figure out how to make a button call up another screen, another activity, using an intent actually. And that's what this is doing here, invoking the activity. And then you can also, in this particular case, we're invoking another activity over here. So we're going to invoke two activities. One's called static. Invoke static for a static variable. The other one's going to invoke a message. The OK button here is going to send us back to this one and send up a little toast message. This stuff we've actually done. This is a different scenario, but we've done the equivalent to this. In our case, we looked at, in one particular intent, we looked at looking at a received message from a result from an intent. The result can do this. This is just a button click. So on here we have a button click that sends an intent back here, which is really should be used with a return result. So the return result of a button sends from one calling intent to another, should send the activity back to the original intent in this particular case. So here's a form, you click on another screen, you type in a message, you press OK, and the message appears down here. We can also do what's called a shared variable. Very common in other types of programming, and this is what makes Java so fun actually. And Objective-C is really hard. No one writes Objective-C code. And no one, I mean, not, okay, people do, I should say. Your average PC user is not going to ever touch Objective-C, but they might touch Java. And if you have some Java skills, and you can keep a shared variable among different instances of classes and different things, you just update, and every activity can look at that and it can update it for you. And we're sharing information between all the different screens. We can share it in a database, we can share it in variables, we can share it in a text file. Many different ways of doing it. But if we have some shared variables here, then we can look back and forth and change the values in the shared space that's associated with the variable that we're keeping track. And then we don't have to send the information back and forth. We left one activity, we go to a new activity, we change the value of x to something else, and then we take and we return back to the original activity. Very commonly done, especially if you have your classes designed correctly, so you're going between the classes correctly. So here's reading from a shared space, writing to a shared space. Don't worry about all the arrows and everything that's happening in this scenario, but it's kind of going through the concept of either using an intent or using a shared piece of memory. So you create 2 sub-activities. We've done this actually. We create 2 classes with 2 layouts. We've done that already. So we have one object or class that's being controlled by one layout and one by the other. And then we invoke the 2 new sub-activities, having the sub-activities return results back to itself. And then we can read the results back in the sub-activities from the main activity. We've done this, so we don't necessarily need to go through this again, but we go through a file new. And now we can cut and paste and copy the onCreate method from one activity, change the layout, copy and paste it to the other activity, change the layout. So we create the 2, and there's a new button actually now that creates the layout for us, as we've seen. That, you know, if you don't want a layout, you have one anyway. So invoking the sub-activities from the main activity, we know that we are editing or we're changing the manifest file to include both activities. So here's the code in red that's actually, this is the manifest file, by the way. And in the manifest file, excuse me, this is the main activity file, not the manifest file. This is the main activity file with the onCreate method here. The onCreate method of one of the activities. And so we have this, we're going to implement both of these concepts all in one. We have a shared variable, and then we also have intents that we can use to bring up the different screens, different activities. So the name of the main activity out here, this is going to be the intent for the get message activity. And then we have the interaction from the message return. So this is where we have that start activity for result. This is the intent that we're creating. You're going to be doing this over and over and over and over again, depending upon what you want to do, which is the way you're going to design the behavior, so that when you're done from one, you send the result back to the calling activity, so you can use the intent to communicate back and forth. And then down here you're doing the same thing again with the another button here to return back. So you're putting an on-click listener on it, and then on the click you're having an intent for static activity intent. This is message activity intent. These are two different activities from the two different buttons that are in this UI up here. This is the code that goes along with these UI. We have two buttons. One of them is going to send us here, the other one's going to send us up here. And the code is very similar, actually. This code is almost identical, except for one is going to start activity for a result, the other one's going to start activity. And some of you noticed that there were different methods that can be called on the start activity for the behavior. And let's see. So the interaction via the message return, the message comes back from the intent. And so we can take the message and use it for something, to update something. So on the click. So here's the invoked of the click button. We start the activity from the result. And if you were to see this graphically on the OK button click, the OK button click comes back, creates an intent, and then puts the extras, which is the return message that's coming out of the box that is being filled out in this particular form. And then it's going to be called message, and then set the result activity to result OK, and then initiate the intent. And then finish gets rid of us. We haven't been using finish in some of the examples that we've been put together, but finish is essentially going to break us down so that we're no longer in memory. What does that mean? Next time we load up the intent to load up the new activity, we load it back up into memory. So we can't go back to it if it's finished. So it depends on which order you're going through, how much memory you have, how many intents you're actually running, what you're doing. So build an intent and then return the result message out of here. And then receive the message. So on activity result, which is that method that's going to automatically be invoked when the called activity comes back to the calling activity, the one that called you. And then we're going to essentially take the case in which the message is something and then work with it somehow, take a string out of that message and use the string for something, update a label or something like that. So then we have the interaction via the message return. So we have a sub-activity for the message return. When we click the OK button, we're going to return to the main activity with the result via the intent, or the message that's via the intent. And here's the intent, new intent put extra. This is in the button click for the message that we're going to send back. So on click listener, we're going to say and the result set is going to be the activity result OK. So it's going to return, hey, I responded back OK. Here's my result from the activity that I did at the new view, on the new activity, and here it is. So it delivers it back and forth, which is basically how the intents are working. And then the message that's being returned in the main activity, you can receive the message from the sub-activity by overriding the onActivity result method. When you override that, you can receive it. And this stuff in red's the overrided kind of changed part where we're going to say the return message is going to be the data.getExtras. We saw this in a couple of the example projects we built today. So you can kind of sort of see what the textbook information says on that. It's using the message itself that's being sent back by getting the extras. Instead of putting the extras, you're getting the extras that come out of that. So interaction via a static variable. So invoke the button clicked, we can go start activity. Now instead of using the one for the message result, we're just going to start the activity. And then when the OK button is clicked, we're going to say static.storage.message equals something and store it in an object. So if we have an object, a variable, something that's shared among all the different activities, then we can use it between any of the activities. So we're sharing data. So the message here, static message text view.set text to equal this message in this particular object. So we're reading the static variable, writing to the static variable, reading from the static variable. So, which is kind of interesting. Actually, the logic of the tic-tac-toe game is pretty much done with, we have a game. So we had one activity that made an instance of game 1, or an instance called it game 1, set the context view to game 1, ran the tic-tac-toe. Well, we can have another activity in the same project that also runs game 2, runs game 3. We can have multiple games going on simultaneously within the same app. We can actually also take and create, put those in a special package, include the package, include the files, and then use tic-tac-toe game in other apps that we build. So you can have like a main app that has like a calculator program with tic-tac-toe with a couple of other things in there as well. So you can have multiple games in there. And what you're doing is you're not tying the code or the activity to that particular app. You're reusing the activity, which is what people do with those controllers. So for like the list view adapter, I should call them adapters. So in Android they call them adapters, in iOS they call them controllers. So the adapters for the grid view, table view, list view, all those different views, layouts that we looked at that were controlled through the adapter, the basic adapter, list view adapter. Those actually, you make it once, you use it over and over again, because it's separated out into its own class file. So you just use the class. Once you've created a really nice grid view, in fact you have one, you're not going to change it, you might tweak it. You take the files, you add it to the new project that you're creating, and you just add different stuff in the grid, or you add different stuff in the table or in the list. The list one, I guarantee you'll probably use for something if you build your own, because lists are very common in terms of the interface design. So what most people do in the beginning is they program by example. So you take the example and you go, I need to create a grid. Then you go, oh, grid view. So it's nice, and save those examples. Actually, it's kind of nice to be able to have an instant grid view, an instant list view, and then populate it with what you want. So the problem is then you're changing the code, and when you change the code you make errors because you don't know what you're doing, or so then you have to learn what you're doing so that when you modify the code you're not gonna like set the balance off or something like that. Or start hard setting strings instead of using the string feature, or do things wrong, or I don't know, change the inheritance somehow. So the more you know about Java, the easier it is to edit the code, actually, to edit examples, but you'll get that with some practice. So interaction with the static methods by defining public static variables. Both activities can share the same static variables. So a lot of people design, and I have a calculator program I'm going to show you next time that keeps values in a, from different methods that deal, different methods and different classes that deal with different parts, can keep track of using shared variables. Data that's collected is stored in memory, in a memory object that's stored over here for a sub part of the calculation. So you can actually kind of juggle it around and use it like a memory, kind of like a memory component or something. So create a new class, call it static storage in this particular case, and have the class store the static variables. So name the package as any other file, and then store in here the static storage and put in the string inside of that. So use objects liberally. Use them for everything, which is what you're supposed to do in object orientation. So if you have a separate object that stores everything, then you might have a storage object. And the storage object is going to be called the message, and the message is going to have multiple parts to it. And then even if you don't use any methods on it, which you probably will, get name, set name, stuff like that on the object, then you can easily translate that into a stored memory kind of concept. And then make it visible, and then port it and use it, and you have one instance that's shared by a lot of different activities that are going on. What you don't want to do is build your entire application into one main activity. And believe it or not, I've seen that. You open up people's code and go, it's all in one class. You go, whoa. And sometimes they put multiple classes inside of that one class too. And then it's amazing that it actually sometimes it compiles correctly too. So think about if you haven't done it yet, think about taking a Java course to learn how you're supposed to design your object-oriented program, follow correct object-oriented design philosophies. At that point, what you're learning in here is how to create the views and the windows and how to get the windows to this activity to load that activity and send information back and forth, which is really the learning objective of this class. So I'm not going to teach you Java programming, especially not now. So static storage here, we're just making and using this object.message in here. So I'm not going to go through the code, but actually this code should look familiar to you at this point. More you look at these examples, the more things will start looking familiar, and you'll see the basic pattern. Every activity has an onCreate. We actually have an onDestroy and onResume and all those other ones, and then the life cycle tutorial has all of those implemented. Every activity is going to have use of buttons, edit texts. I mean, not every, but most will. OK buttons, text fields, edit texts. So common components. You make instances of local variables. You go out to the context. You set the context view to the layout you want. You go out there. You get the items from the r dot whatever layout dot whatever you're looking at, and then you bring them in and you assign them to local variables. You use them around, and then eventually you print it back out to the variables, so you can update stuff on the interface through the layouts components through the IDs. So you're using those IDs to get a hold of that component to do something with it. So the interaction with your static variables here, the main activity access is through onResume. Because if, for example, and this is why the life cycle is kind of interesting, if your activity is out there and it creates you have a button and it created an intent, loaded up another activity, what are you doing? You're paused. So if you're paused, you're not doing anything. So when the other intent comes back from its activity and it's going to call you again, it's going to return, you're going to get the result hopefully, or maybe you're not looking for a result, but then you're going to resume. So on a resume, you have an entire method that's going to do something for you, just like the onCreate, onResume, onDestroy. So this is going to set, as an example, set the text to whatever message that came back. And from our Android manifest, we know we have to add the two sub-activities to it in order to give control of the phone to actually use the activities. We're basically setting the activities with activity tags. All we have to do is tell the manifest about it. Really, it's really much all we have to do. And we know about the strings. We saw that today as well. We added activity strings used in the manifest. We can actually add the strings to the manifest string name, and then we have this app underscore static underscore message activity, and this is going to be a static message activity string. So we can add strings in there for the names. These are the names, by the way, of the activities that we're putting in there. So that was kind of a summary overview of all of the tutorials and stuff that we dealt with that worked with intents. What I want to do now is kind of give you the summary info and kind of lay down, and these tutorials are all available to you. You might use it just for reference, but it's nice to see a conclusion after you've been working with stuff. So what I like to do is tell you what I'm going to tell you, and then tell you what I told you. So I'm telling you what I told you. So at this point, graphical user interface, because at one point you're going to go, oh, that's what a layout is. And hopefully it's not right now. Hopefully before you walked in this morning you knew what a layout was. Hopefully. You don't know what menus are yet, but menus are next time. So the widgets, menus. Alright, so familiarize with main GUI components. We have a hierarchy. We have a view hierarchy. When we load up the app, the one and only line that's the most important part of the onCreate method is this one here, set context view. It's in every single app you're going to build. It's in the prototype. When you create a brand new app that doesn't do anything, hello world, it has a set context view. This is the XML file for your layout. It's the root view. So it's the root node of the hierarchy of what it is you're going to load. You can do it programmatically, or you can do it by dragging and dropping, or you can edit the XML code. We have many choices with that. So all views in the window are arranged in a tree. You show the tree by calling the set context view with the root node in the main activity. So we have this concept of a view group. The view group contains another view group, or it can contain another view or another view. So view groups are the ones that have multiple views inside of them. We group them together. So we can categorize multiple views together. If you start looking at now, go back and look at the layout code for you'll see groups. You'll see view group. View group as a classic example. Everything is a view, by the way. Every view component widget is part of the view. So we can take the window as a view. We can take the button, an image. We can take all these little components and call view or ask for a view, and we get what it is. It's all a bunch of hierarchies of subviews. So in a lot of the code, if you go and look at the ones that use the nested, they'll use a view group. So you'll see view group. What is it? Well, it's the grid item, and the grid item has the image view and it has the text view. So it used to be in the old days everything had edit view, image view, text view, web view. Some items still do. That's where the view is coming from. This is what it means. This is the view. And we have view groups. What are the view groups? A list is a view group usually. So you create the view groups. You can do it by nesting the components in the XML file. You can also do it programmatically. More often it's done programmatically. You'll take a bunch of items, you'll stick it in a view group. And the view group is going to be the grid items, the table items, perhaps, or maybe the list items. So in each one of the grids you have a separate sub-view that's a group of items, and the group of items in our case for both examples was an image and a piece of text. The text view is viewing a piece of text. I know they call it edit text, which is kind of weird. I don't know if they call it text view anymore either. View text or something, I don't know. I can't remember what the components are called these days, but it doesn't really matter as long as you use them. So what do we have here, and what we looked at was this hierarchy, and here's our layouts. So to give you the conclusion on the layout concept, here's our linear layout on the top. Everything actually comes from linear layout. In the old days, the project type used to be linear, and then people used to stick a relative in there. So now the relative moved up, so the slide's outdated. It's almost like the relative and the linear are almost at the same level now, which is kind of weird. So the layout defines how the elements are positioned relative to each other, next to each other, underneath each other, in a table, in a grid, in some sort of a format as we've discovered so far. You can have different layouts for each view group. So the view groups can be specified out. So on your window we've only seen single view groups. Yes, single. We can actually divide the screen out and have a scroll list box on the top and a web view on the bottom and something in the middle. We can take different view groups and stick them into the layouts and then use different layouts. So we can have a relative layout with a linear layout with this layout, and we can put layouts inside of layouts. Next time when we come back, we start nesting layouts. And we start nesting groups and putting groups inside of groups and stuff. Then we start working with more convoluted configurations that work to give us visual effects. See, unlike the iOS, iOS is all about the wiring of the components, I believe. You know, I don't know. I shouldn't say that. I'm simplifying it. The GUI is extremely easy compared to the Android side of the fence, where the GUI is not so easy. There's an abstraction of a hierarchy you have to deal with. You don't have the same level of having to. You can see the abstraction. I believe you can see the abstraction a little clearer in the iOS platform than you can in the Android platform, which is one of the biggest complaints. However, I would say the exact opposite of that with the programming point. I can see the Java code extremely easy, and I can see the programming part of the app much clearer than the iOS. And it's not the difference between two different programming languages. We put them side by side. Java's a lot easier than Objective-C to begin with. But the connection of the source code with the GUI and the controllers, we have the data app delegate, we've got the view controllers, and we've got all of those little components. We don't have any of that in this environment. This is actually simplified. So we have that kind of benefit working in our favor. But unfortunately, the downfall is in the sub-nesting of all the different layouts and getting the layouts to actually look correctly. So in this slide we have a linear layout with a relative layout, you can switch around the order. Just because this one's up higher doesn't necessarily mean anything, but inside of your relative layout, you can put a linear layout in here. You can put a linear layout inside of a view. You can have multiple views that are all inside of a linear layout with multiple subviews that are inside of the relative layout. As soon as you put a new layout tag in there, in fact, you might want to play around with it. Put a layout inside of a layout inside of a layout inside of a layout and stick components at each one, and then you look at it and it all looks like it's on the same screen. It is, but it's controlled differently. So you can hide and show the different layouts. You can move the layouts around, you can organize the layouts differently. It all depends on what you're going to do with it. But, you know, it can make it convoluted. This has got many different, this screen's got like different layouts on it actually. In fact, that's the code. That's the layout configuration for this screen right here actually. Which is the same as what we were looking at the beginning slide. Then we have widgets. All the view objects are widgets. So we have text fields, edit fields, buttons. So we don't have views anymore. We have they call them fields now. Text fields, edit fields, buttons, checkboxes, radio buttons. All the different things are called widgets. They're all inside of the views. They're all view objects. They're all inherited from view. So you can get at all of the objects by asking for the view. So you see some of the methods that go for on-click. One of the parameters will be view, view. And you go, well, view, what is that? It could be anything that you're getting out there on that view. So you're looking at the component and you're going to check if it's a button. Is it a button on the view? Then if there's a button there, then what's the button ID? If the button ID is this, or what's the button label? If it's this, then put up a screen, button was pressed. If it's a text box, then put up a thing, you know, get the label, get the ID from it, and put up another prompt that says, hey, the text box was touched or something. Which may not be a bad activity, actually. I believe I have a project, I just haven't uploaded it yet, that looks at touch controls. And touch controls are something we'll be looking at the next time around as well. So we've only hit the surface. We have 2 more weekends of this class before we hit about 80% of all the utility. We have, what are we going to do next time? Oh, this is a slight tangent off the lecture. Next weekend, intermediate weekend, this is the beginning weekend. The intermediate weekend, we're going to look at maps, nested views, hierarchical views, touch controls, navigation. We haven't even looked at navigation yet. And the idea of adding controllers, and then the multiple activities nested with controllers with multiple functionalities to create more sophisticated applications. So we take this level, we build it up a couple more steps by taking the components we already have and working with them. So by the time you come back next time, please have working systems. All your bugs should be worked out because we can't troubleshoot working problem. We can do it in the beginning class, but at a certain point, you got to move forward at that point. Otherwise, you're not going to be able to pick up the more advanced concepts. So for those of you who did have problems actually in your install and haven't gotten things working correctly, you got a couple more weeks. Go over those examples. See if you can get all those examples working, all those tutorials working. Do the first assignments actually, and then you'll be in great shape for the next one. So it's baby steps. So, all right, going back to the lecture here, UI events. So we've seen UI events through handlers, usually handled by defining a listener. We saw listeners. We listen on something. So we put a listener on a button, we put a listener on a text box, and then we register it with the view. So when the item on the view has been touched, has been clicked, has been something, we get the on-click listener, the on-touch listener, or on the on-key listener. We can put the listener as we've seen with the on-click. Only problem with that was we only have on-click. Some people immediately went, oh, you know what, I don't have to do a listener. I can just put it on the property of the button and use that forever. It only works with a button. It only works with the on-click. There's no touching. There's nothing. So whatever the person, you can't pick up a click. Most phones will interpret a click like a touch. But if you have touch up, touch side, drag, move, gesture controls, can't be controlled that way. So it's kind of okay, makeshift kind of way to get simple examples to work, but eventually you're going to want to use the listeners, because then you have more control over what you're listening for and what event you're actually going to capture. On key listener for handling keys on the keyboard. Alternatively, overriding the existing callbacks if you've implemented your own class extension of the views. Menus. We haven't seen this yet, but we've seen the template that keeps showing up in every one of our projects. We have a different XML file for that, and it's usually called the same name as the main menu. So it's activity_main.xml, and we have activity_main.xml that's used as the menu. It's just stored in a menu folder instead of a layout folder. What do we do there? We write the XML code to add the menu items. Here's some menus. We have the options menu, which I believe is what we're going to get actually by default with the default project that we create. So next time we're going to create some options menus as well. Context menus. Context menus come up when you, okay, options menu, you usually have to press a button on the phone. That's that little, on your emulators that I gave you, that's that little round orange and white thing. It's the button on the phone. It brings up the menu system that comes up on the bottom. That's the options menu. Context menus, when you put your finger on the background of the device or you long click with the mouse and this menu comes up out of nowhere. This is a pop-up menu that came out from some event that occurred in the context of the application or the activity that you're working with. And then here's a sub-menu that came from maybe clicking on one of these items. And you have a sub-menu that came out of that. So we'll be working with some menus the next time we meet as well. So here's the concept of it. We have a menu item, and then we have a sub-menu. So a sub-menu has 0 or more menu items, which have 0 or more menu items, which has 0 or more sub-menu. Well, the sub-menu is the sub-menu for a menu item. So in here we can have this lead to this, leads to another one of these, leads to another one of these, leads to another one of these. It's kind of convoluted. What do they say in web development? Steps of 3. So if the clicks or the navigation goes past 3, the user can't remember it. So it's file, open, new. It's a run, run, application type. So 3 steps. So normally you're just going to see 1, 2, and maybe you'll see another one. Maybe it'll go to another menu, but you don't want to nest them too deep. It makes navigation hard, actually. You know, it's like all the rules they tell you on color. You know, when you make it and it looks like a clown got put through a blender and put out on your app. Actually, there's a ton of those apps. You can see them in the I'm going to do this one in localization. You can see them in the App Store actually with because I kept talking about localization. This is only 5 slides, don't worry. I know you're like, I want to go. It's only 5 o'clock. I'm almost done. All right. Then I reserve some time at the end to troubleshoot people's problems. Okay. Anyway, what was I talking about? Localization. I lost my train of thought here. I just want to finish with this concept because I started with this concept. Because I want to make sure I have ingrained in you that you need to use the strings. The goal, in fact, there's an assignment on this as well. I believe it's the 3rd one. Is it the 3rd one? The 2nd one works with localization. So you'll be doing a tutorial if you choose to do those assignments, which probably not a bad idea to work on. That way it would reinforce your learning of this weekend. There's one on localization, how to localize an application. What does that mean? Over here it says no localization. The dialog list here says that it's not localized. Well, the phone gets localized. And most people don't remember it, but when you turned on your phone initially, it asks you, what language would you like to speak? Every phone does this. iPhones do this, Android phones do this. It's called a localization. Most people just press English and then they continue, or they press whatever language they're in. So in the resource file, we have the strings. Here's our string.xml file, and we saw this already. This is coming from the localization, hello localization tutorial that you have out on the website there. Some people have removed the other languages. So this happens with Mac computers all the time, actually, and devices. There's options that say, you know, there's like these clean utilities. So testing this might be a problem if you've done this to your phone, which basically says, you know, who needs to leave all that language on there for all the base menus and stuff if you're not going to use it. So you press a button and I said, would you like to remove all those extra languages? Because it frees up like a lot of space maybe on your system. Who needs it unless you're going to switch back and forth between languages? Nobody does that, right? After you pick the language you want, you remove all the other languages. Well, the idea here is if you have an app that you're creating and you're using strings for it, then you can customize the strings for the different languages. So it can check to see which localization is being used on the phone, and if it's French, you'll show the strings in French. If it's English, you show them in English. It makes your app a little bit more universal and international, I should say. So here we have, shall I compare thee to summer? I don't know what these text messages are. These are just text messages that are in this string.xml file. And then we have a drawable flag for each one of the languages. This is coming out of the tutorial that you'll be working on, and you'll see how to do this hands-on. So we have a local code, and these are the codes, and we create different string directories for each one of these. So you don't really need to know a foreign language to play around with this, actually. You'll have a translation that works for you. So you change the locale to English in this particular case. If we changed it to Spanish, Spanish Spain, Spanish Venezuela, we will have different things happening. What is it, listos? Listos, doesn't that mean ready? Listos? I don't know. What language is Spanish? I don't know. I'm not going to try and read the Spanish, but long story short, the second tutorial that you're doing, the second assignment will have you do a localization tutorial that will walk you through creating this project. You can download the flags actually from the android.developer.com or developer.android.com website that will give you all of the PNG files and stuff for this project. You can also run through and see how the strings are created. But if you do this, you'll see that there's different folders for different languages, and you just load different string files depending upon which localization set. You can actually set the localization in your app as well. But I will leave that to you to do in the tutorial. And the tutorial is actually quite fun. It's on the developer site. If you're here at the beginning of the course, I went over it. If you missed it, go check out the video. Alright, so this concludes the weekend. We've successfully, I'm going to wait around. We're not quite done yet. I'm going to wait around to fix problems for people. We're still having problems. We still have about, technically we still got about 45 minutes or so left of the class, but it's okay. I think we've gotten enough done. We've accomplished everything we needed to accomplish. So after I get done, you can leave if you want. Know that Wednesday night, if you're interested, we have a 6 to 10 in the auditorium over here. A guy from Microsoft who's coming in, who's going to give us a tutorial, 4-hour tutorial on Windows 8 app development using third-party tools. He says he guarantees a student can create an app for the Windows Store in less than 5 hours. So if you do, he's going to pay you $100 per app you put in before April 15th. And he's going to give you a free app development license. So you can, I don't know, what is it, $49 or something? I don't know. You have to pay to actually join up to this Windows developer program. Anyway, free developer. If you go to the workshop, you'll get a free developer account, and then you'll be eligible to put an app in there and you get paid $100. And I said, well, what does it matter? What kind of apps? He says, oh, they can be crappy apps. Just apps, right? That tells me they're desperate. Are they really that desperate? But they're going around to all the universities in this area in California, and they're trying to get all the state universities and stuff. They're trying to get students to make apps and put it into the store. So he's given. They don't have much in there. So he's giving away DreamSpark accounts. That's Microsoft DreamSpark. If you haven't heard of it, you can download free software. Apparently, he's giving away versions of Windows 8 as well. I don't know what kind of versions these are, because he said you can bring MacBooks, you can bring PCs, so apparently they're probably emulators, probably using VirtualBox. He's probably going to do something like what I've done. He's going to have USB disks. We don't have to worry about down, because I already told him that we get download issues at this campus. So he's going to put everything on USB disks. I don't know if he was giving away the USB disks or not, but maybe he's going to have more than one. So I don't know how many people we're going to get, but apparently, you're supposed to be able to build a Windows app, and it's a free workshop, so you don't have to worry about it. And there's supposed to be pizza and soda too. So I don't know. I'm going for the pizza, and I'm kind of curious. What this guy's gonna do. And I want my $100 for my. There's a max though. You can only put 20 apps in for the $100 each. Maximum, you can make $2,000 on this. Well, I'm gonna try it out. So anyway, we're not doing anything. It's this Wednesday. Starts at 6 o'clock. It goes to about 10 o'clock or until when people burn out on it, I guess. So. And there's no sign up, you just show up. Okay, so the next time we're going to see you guys, just so you know, the next time I'm going to see you is not too long ago. It's going to be pretty soon. I'm going to see you guys March 30th and March 31st, which is going to be in about 2 weeks. So rest up. Get into training. 3 weeks? March 30th. 2 weeks away. March 30th and 31st. Next weekend we have Java. No, Java programming if you're in that class. So the calendar, let me take a look here. Object-oriented, 16th and 17th is object-oriented programming. And then we have, I have a weekend off. I'm going to need one. March 30th to 31st. And then we go back into April 13th, 14th for the last one. So we only have 2 weeks, seriously, till I see you guys again. So. All right. I'm also available by email, bhacker@itu.edu. So, enjoy your time off.